Hi. What do you think of XP's new outfit? At first, I thought he was some kind of fashion victim from outer space, but I was wrong. It's not the latest look on his planet. It's something he's made and designed all by himself for a special reason. Here's how it happened. XP wanted to learn to ride, so I lent him my bike. He fell off quite a lot, but he said it wasn't his fault. XP, are you okay?
Yeah. Oh,
Look at my wheel. You bent it. You were going too fast.
no, it wasn't.
Well, why did you fall off then?
Well, maybe it's because the Earth is round. I bet I wouldn't have fallen off if it was flat.
Oh, you've got an answer for everything, haven't you? Just look at my bike.
Why is the wheel bent, Sarah?
'Cause you bust it.
Oh, all I did was fall off. Something else must have bent the wheel.
Yes. And what about mending it again?
I'll tell you what, Sarah. I'll take it to be mended if you help me find out what bent it.
Okay, you win. How shall we start?
I'll use my scan-do to access your computer by remote. There. We can look up the information from here. See?
Wow, neat work, XP. Okay, type in crashes. That's C-R-A-S-H-E-S. Ooh, crash tests, crash forces, crash safety, and the highway code.
You choose, Sarah.
Okay, crash forces.
These are forces at work. Two forces that we use all the time are pulling forces and pushing forces. One of the best places to see forces at work is in crashes like these. All these crashes show the result of forces in action. Here, a force is needed to push the car. Here, a force is pulling. Here, a force speeds the car up. And here, a force slows the car down. Select More to see where the forces are.
Press more. I want to see this.
The arrows show where there are forces working. The bigger the arrow, the bigger the force. Here, the bigger force pushes the cars. Here, the bigger force is pulling the men. Here, the bigger force speeds the car up. And here, the bigger force slows the car down.
I don't quite get it, Sarah.
Well, I do sort of. See, it's like there's forces working on all the things around us, right? And then when one of them's greater than another one, it makes something happen.
Like crashes.
Yeah, and other things, I guess.
That will make a great topic for an inquiry.
Why don't you start one then? What else is there on crashes?
Crash tests, crash forces, crash safety, highway code. Let's do crash tests.
Okay.
Scientists and engineers crash cars on purpose to see what would happen if they crashed in real life. They do this at special testing centers. This one belongs to MIRA, the Motor Industry Research Association.
Some crash, huh?
That's the place to go, Sarah. I'll find an expert on crashes and ask him about these forces.
Good idea.
Disconnecting. Express -3, 2, 1.
Oh, you forgetful feather brain.
Scan to identify. Audio on.
Activated. Scanning. This is the MIRA crash test site.
Hello, little chap. Are you lost? Is he with any of you? Anyone from Earth here? No, don't get upset. Like a crisp.
This is Roisin. She is an automotive scientist.
Hello, my name's XP. This must be yours.
No.
Oh, yes, it is.
No, this is a dummy.
A dummy. These are all dummies. What are they for?
They're used to help measure forces in crash tests.
In crash tests? Can I see one in a test?
I can show you one on video.
Great. Dummies. Yes.
Okay, let's go to the screening room.
No need. I can put it on my side screen. Just hold on to the baby. Thanks very much. And the crisps. Thanks very much. Activate side screen. Audio on.
We use crash test dummies to find out what would happen to real people in a car crash. The dummies are put in a test car and connected to computers. When the car crashes, the computers measure the forces on the dummy. Dummies help us to design cars to be safe for humans to ride in.
Wow. Can I see where that was done?
Yes, walk this way.
Great. So, this is where the crash test dummies do all their work, is it?
That's right, and this is where we crash all the cars.
I see. So this car will go down this track into that barrier.
Yes, that's right.
Would you mind if I had a go?
Not at all.
Oh, thanks very much. Activate scan field. Select speed factor M. Stand by, Smart Specs. Smart Specs. Scan to inform.
Activated. Informing. You were running in a straight line towards a solid barrier. You then hit the barrier. The force of the barrier acted on you to slow you down to a stop.
You okay?
Oh, yes, I'm fine. There's one thing I don't understand. I was moving at speed, but the barrier slowed me down. How did it do it?
It was pushing back at you.
How was it pushing back at me?
Come on over here and I'll explain.
Oh, right. So you're going to show me how this wall is pushing with a force?
That's right. Lean on it. You see, it's not falling over. You're pushing on it, but it's pushing back on you with an equal force.
Ah, so if I wanted to push it over, I'd have to push it with more force than it was pushing back on me.
That's right. Let's take another look at the video and I'll give you a commentary.
Right, I'll just make a note of all this. Scan to record.
The car has a force making it move towards the barrier. The barrier pushes back with a force, like the wall that you leaned on. The crash happens when the two forces act on the car at the same time.
So now XP knew just how my bike wheel got dented. It was because when the force of the bike met the force of the tree won.
Oh, right.
Rasheen offered to show him around the site, so they set off to have a look. Meanwhile, I'd taken my bike to be mended, and had found out some more about forces too, especially ones to do with bicycles.
Even when a bike is not moving, there are still forces working on it. The weight of the bike is a force that pulls down, and there is a force from the earth pushing back up against it. The bike stays still because the two forces balance each other out. When the bike starts, there are more forces at work. This time, they are not balanced. The force the rider gives the bike pushes it forward. This force is bigger than the friction force holding it back. When the bike is going at a steady speed, the force pushing the bike forward is the same as the force stopping it. Because the forces are balanced, the bike doesn't speed up or slow down. It just keeps going. But when the bike is slowing down, the forces are out of balance again, but this time the other way round. The force slowing it down is now bigger than the force pushing it forward.
Bet he was going too fast when he buckled my wheel. I'll go back and try and work it out. Yeah, I'll carry out an experiment of my own. Yeah. So I went to fetch my bike from the repair shop. XP was still at the crash test site having a whale of a time. He was watching Rasheen testing a bike helmet.
Smart Specs. Scan to explain.
Explaining? This test shows how helmets protect what is inside them. Without a helmet, the melon got squashed when it hit the floor. The force of the moving melon met the stronger force of the ground. The melon was weaker than the ground it hit, so the melon broke and not the floor. But when the melon was inside the helmet, the force of the floor was absorbed. The helmet was damaged by the force, but there was very little force left to damage the melon. So, the melon survived. People protect all kinds of things from forces in the same way.
And that's what got XP started on his road safety inquiry. I took my bike to test it and make sure it was okay. I cycled past the place where XP had his accident. I was still trying to work out how he'd had his accident in the first place. I went along the same route he did, and I could stop the bike easily. I tried again, going faster, but I was still able to use the brakes to give me a stopping force before something did it for me. Well, I reckon he must have been going way too fast. In which case, I should be able to spot the tyre tracks where he jammed on the brakes. It's a flipping mystery. Unless he didn't see the tree at all. Now that's very unlike XP. I wonder where he is right now.
Smart specs. Prompt to recall. Topic: airbags.
Recalling. Airbags help protect people in a car crash. When a car hits a barrier, the airbag blows up very quickly. The bag acts as a cushion, stopping the person from hitting the front of the car.
What are you doing?
Blowing up my airbag, but it doesn't seem to be working.
Not for a bike. You need these. Elbow pads to protect your elbows.
Ah.
Knee pads to protect your knees.
Yeah.
Gloves to protect the backs of your hands.
Yeah.
And of course the helmet.
Aha. This has given me a great idea.
And that's what XP wanted me to see. His new safety outfit. He'd heard so much about how forces can squash you and crush you in accidents. He didn't want to take any chances. Between you and me, I think he overreacted just a bit. XP, look, I borrowed my friend's bicycle for you to practice on, but first of all, you know when you fell off my bike, you did see the tree before you hit it.
I certainly did.
Well, in that case, you must have been going too fast, else you could have braked in time.
Braked?
Yes. You do know bicycles have brakes, don't you, XP? You don't know bicycles have brakes. XP? Don't answer then. I think it would only upset me anyway.
Never mind. I learned all about how you can protect things from forces. I'm going to try it with eggs later. But first, let me show you my latest invention. The intergalactic IM safety suit.
IM.
I made it myself. This suit will protect the rider from being hurt in crashes. It has every known safety feature, and a few more besides. It's easy to... I can't get on, Sarah.
Oh well, there's a force that will come in handy for you then, isn't there?
What's that?
A pushing force. Gotta go now. Disconnecting. Hi. I'll give you 3 guesses who got me into this mess. Actually, you only need 2. One for the X and one for the P. Can you believe this is a concrete boat? And XP has talked me into being the passenger. He didn't mention I was going to be the only passenger and that this thing doesn't have an engine. See, it's all part of one of his inquiries. It started when he was in the park. There were some children there playing a game. You know, the one where you drop sticks in the water and race them under a bridge.
Where are they? Don't worry, they'll be coming in a minute. There's mine, I won.
Anyway, XP thought it seemed fun and wanted to try it for himself, but it didn't quite go as he expected.
Activate smart specs.
Activated.
Investigating water. Question, why do some things float and other things sink?
Suggest you experiment with floating and sinking.
But first, to rescue my cosmic screwdriver and my Scandoo. Now, to do some investigating. Right, what shall we start with? Just what I want. Sample 1. Wood. Result, it floats. Sample 2. A pebble. Result, it sank. Now let's try some other things from my pockets. Aha! Sample 3, plasticine. Result, it sinks. Sample 4, a crisp packet. Result, it floats. Sample 5, a cork. Result, it floats. Sample 6, a ruler. Result, it sinks. Let me see. Is there a pattern to all of this? Is it that flat things float? No, the ruler didn't float. That's not right. Maybe it's that wood things float. No, the crisp packet floated too. Maybe it's that round things always sink. No, the pebble and the plasticine sank, but the round cork floated. Oh, it's all very confusing. Time to call Sarah, I think. But first, to get my ruler. Oh, where is he?
I do wish you'd knock sometimes, XP.
Oh, sorry. What are you doing?
Well, I'm weighing myself. So we're doing this lifestyles project thing in school, and I was just filling in the chart. How tall do you think I am?
I'll tell you, exactly. 148.6244787244664466 centimetres.
Wow, Miss Watson will be impressed with this.
Good. I'm doing an inquiry.
And you want me to help you look it up on the computer?
How did you know that?
Lucky guess. Okay, what are we investigating?
Well, you see...
XP told me what he'd been up to, so he started looking for some information. I said we ought to begin with boats, because we knew they floated. Well, come over here and let's see what we can get on the screen.
Okay.
Okay. Right. BOATS. Choose. History of boats, designing boats, fantastic facts, and famous sailors.
Let's do fantastic facts. It might give me an idea.
Okay.
boats come in all different shapes and sizes. Here are some fascinating boat facts. This is called an air dinghy. It is partly a boat and partly a hang glider. This is a dragon boat. It is a kind of canoe and comes from Hong Kong. They have races every year at their Dragon Boat Festival. Up to 40 people race in each boat. Some boats don't even float. They skim or hover on a cushion of air. That's why this boat is called a hovercraft. Floating on this cushion of air means that the hovercraft can move on land as well as in the sea. This is the Queen Elizabeth. It was the biggest ocean liner ever built. It weighed 82,998 tons.
Flip!
Why flip, XP?
Well, that last bit's mucked up my theory.
What theory?
Well, I thought that maybe light things floated and heavy things sank. But that boat floats and it's mega heavy.
Well, let's look up boat building then. See if that helps. Right, that's probably it. Designing boats.
Designs for new boats are tested before they are built. Models are made from the designs and then put in special water tanks. The tanks allow scientists to test how the boats will behave when they are at sea.
That's what you need, XP. Tanks.
I'll pay a visit. Do you want to come?
I can't. I've got to finish off this lifestyle project thing. I mean, I should have done it ages ago.
Okay, see you later. Disconnecting. Express -3, 2. Oh, Sarah?
Yes?
Tanks. 1.
Sometimes I wished I kept my mouth shut when he asked me what jokes were. Still, at least he's not doing an inquiry about them.
Scan to identify. Audio on.
This is a boat testing laboratory. This is David. He is a boat designer.
I want to find out why my cork floated, but my plasticine sank.
Why do you think that was?
Well, I thought it was because my cork is light and my plasticine is heavy, but that can't be true, because large boats float and they're mega heavy.
Well, that's true. But let's just have a look at the cork and a piece of plasticine the same size. The cork floats because it's light for its size, whilst the plasticine sinks because it's heavy for its size.
Ah, so the plasticine will never float.
Well, that's not so. It can float if you change its shape.
Oh, right. Yes, I'll do that.
Okay. But perhaps before you go, you might like to come downstairs and see our tanks where we test models for big ships.
I'd love to. Lead on.
Thank you. So this is where we run the ship models. And we'll start it off.
What's this for, David?
This is a tank in which we can do some experiments.
Oh, great. And what are these for?
These are two tins, two biscuit tins, one of which we've crushed. Shall we see if it can float? Well, that one sinks fairly obviously. If we look at the second one, floats easily. In fact, we can even put things inside and it still floats.
Scan to confirm results.
The uncrushed biscuit tin floated because the metal it was made of was spread out. The crushed tin did not float because the same amount of metal was squashed into a lump.
Will this work for other things that are heavy for their size?
Yes, it certainly would.
Great, we can do some more experimenting.
Yes, well, if you can do that, because I'm afraid I must dash.
Oh, really?
Nice to see you.
Oh, okay, disconnecting, David. Bye. XP connecting Sarah. XP connecting Sarah.
Connected. Hiya.
What's heavy and you would think would sink?
This isn't one of your dreadful jokes again, is it, XP?
No, it's an inquiry.
Oh, that's all right then. Only I'm just about to start an experiment myself, you see.
Oh, well, what's the answer?
Well, I don't know. I haven't started it yet.
No, what's the answer to my question? What's heavy and you would think would sink? I can't think of an answer.
What about concrete?
That's the stuff. I'm going to build a boat of concrete. Disconnecting.
Yeah, okay. A boat? I couldn't see how XP could make a boat out of concrete. My experiments didn't seem to be heading that way at all. I've been seeing what happens when you put things in water. When I put my tennis ball into the water, it floated. I knew it had air inside it because I saw one the dog chewed, and it was all hollow. I wondered if that was a clue of some sort, so I decided to try something else with air in. I knew my sponge had air in it, and it floated right on top of the water, so I squeezed the air out of it underwater. Then, it didn't float nearly as well. Right, let's try this for Sarah's theory of floating. Things should float in my tank if they have air in them, but I should do another test to see if my theory is always true. If I can make a pocket of air inside this plasticine, then according to my theory, it should float. Oh no, it sank! Oh well, another great theory bites the dust. I decided there was only so far I could go without a bit of help, so I typed in float. F-L-O-A-T. Choose. Why things float, fishing floats, water safety, how to stay afloat. I'll choose why things float.
When you put something in water, it pushes downwards and takes up space. The water pushes upwards, almost as if it is trying to get the space back. This push is called upthrust. You'll already know about upthrust if you've ever tried to push a balloon down into water. If the upthrust, that's the force pushing up, is in balance with the weight, that's the force pushing down, then something will float.
XP really should see this. I wonder where he's got to. Oh no, he's going to build a concrete boat. He'll never do it. He doesn't know his upthrust from his ear hole. He'll drown himself. Fortunately, he left his scan-do behind. It scanned to show me where he was, and I dashed up to rescue him. Only it turned out he didn't need rescuing at all.
Sarah, look, a concrete boat.
Oh, wowee! How much concrete went into this?
Oh, it was a heavy lump, about that size.
So has the boat got a name?
Yes, I call it Heavy Lump the Third.
Why the third?
The first two sank.
So what makes you think this one won't?
Well, I asked David for some advice. David, do you think you could tell Sarah what you told me?
Yes, certainly. Sarah, what do you know about floating?
Well, I know that weight pushes down and water pushes up.
Well, that's fine. So the reason why this boat floats and that concrete doesn't is because it's much wider and it can push more water out of the way, and therefore that can provide enough of the force to keep the boat from sinking into the water.
So which way round is it then?
Well, that's the front of the boat. We normally call that the bow, and it's shaped like that in order that you can pull it through the water more easily, whereas the back of the boat is very flat here, and if you try to pull it this way, you'd find it was very difficult to keep it going straight.
So have you found a test pilot for your boat yet then?
Well, it's, someone you know, actually.
Is it?
Yes, quite well. In fact, very well. In fact...
No, XP. Not me. No way. No how. Not ever. No thank you. N-O spells no. Honestly, he could sell electric fires to snowmen, he could. So, here I am with no sails and no engine. Mind you, it does float. That's the main thing, I suppose. Actually, floating around here has given me an idea for another inquiry. I am going to try floating plasticine when I get out of here. If I get out of here. Talk about being up the creek without a paddle. I know. Scan-do. If he can work it, I can work it. Express reverse minus 3, 2, 1.
What's happening?
You are about to do some rowing, XP. That's what's happening.
Rowing? Oh, no one rows on my planet, Sarah.
My lords, ladies, and gentlemen, I, the great Swarovski, am about to perform for your amazement one of the most baffling magical mysteries ever to be seen on this or any other planet. But first, I think I better explain what I'm doing up here just as the great Swarovski instead of just plain old Sarah. It all started when XP had got hold of a ginormous balloon. And instead of it starting him off with one of his inquiries, like things usually do, he thought of something else.
How did you do that?
With a pin.
No, I mean, how did you know I was there?
I saw you in the mirror.
But I wasn't in the mirror.
Yes, you were.
No, I wasn't. I was over there.
Yes, but I can still see you in the mirror. I mean, haven't you got one?
No,
Well, how'd you brush your teeth?
with a toothbrush.
Of course you do, Space Twerp. But how do you see to brush them?
Oh, with my smart specs. I mean, what's a mirror for?
Well, it shows you things.
Amazing. That's a good topic for an investigation. I'm going to look into this.
I hope that wasn't supposed to be a joke, XP.
No. I'm going to do an inquiry into mirrors. Do you want to come?
Well, I'll give you a hand. But not if it means I have to leave the house. See, I'm waiting for my friend to phone.
Okay, I'll go and do some exploring, and you stay here and do some finding out, okay?
Okay.
XP disconnecting. Express minus 3, 2, 1.
So, XP set off on a mirror hunt, and I started looking up all about them. I used one every day, but I'd no idea how they worked. Mirror. Fun in Mirrorland. How mirrors work. Alice through the looking glass. Better start at the beginning, I guess.
In the dark, you can't see things. You need a light source. A lamp, a candle, or the sun before you can see anything. This is because we only see things around us when light is reflected from them into our eyes. Light from the light source travels to an object and is reflected into our eyes. This is how we see the object. Everything around us reflects light. But some shiny things, water, metal, glass, and mirrors, reflect all the light. If a surface is smooth and flat, you can see yourself clearly. But mirrors turn you around from side to side. When you hold up your left hand in a mirror, your reflection makes it seem as if you are holding up your right hand. Just like your writing looks different if you hold it up to a mirror.
Well, I sort of get it. Let's try this one. Fun in Mirrorland. Mirror mazes, something or other, mirror writing and mirror magic. Okay, mirror writing.
If you hold up your writing to a mirror, it looks different. This is because the mirror reverses all the letters. Some letters still look the same even when they are reversed. Type in your own name to see if you have any of these letters in it.
Okay. S-A-R-A-H. Choose mirror or normal. Okay, I choose mirror. Ah, neat trick. And the A and the H stay the same. I must get XP to try this one out. Okay, what shall I try next? Okay, let's try the second one down.
A kaleidoscope is a toy that makes patterns by using mirrors. You look through it and turn it round at the same time. What you see are pieces of colored paper reflected in 3 different mirrors. The mirrors face each other in a triangle. Their reflections of the colored paper make a pattern. You can easily make a simple homemade kaleidoscope for yourself.
Something else I can show XP. I wonder what else there is. Aha! Mirror magic.
Magic mirrors sometimes appear in fairy tales. But in real life, they can only reflect what is in front of them. This fact has still been put to many amazing uses. Before each Olympic Games, people in Greece, where the first games were held, use a mirror to concentrate the rays of the sun together to light a torch. This torch is then carried to the place in the world where the games are being held. In sunny countries, you can send signals to people who are far away by using mirrors. This heliograph bounces flashes of sunlight to a person many miles away. In the circle, you can see that person sending a message back. Magicians sometimes use mirrors to make their tricks seem like magic.
Right, XP. You wanted to play tricks. Let's see if I can play one. A real one.
Aha! Activate scan do. Investigating mirrors. Scan to record. Activate smart specs. Audio on.
Activated.
Access scan do.
Scan do accessed.
Question: how many reflections have I scanned?
You have scanned 10 reflections.
Question: how many mirrors have I seen?
You have seen 4 mirrors. The other 6 were shiny surfaces.
How many of the reflections made me look normal, and how many of them made me look all funny?
5 reflections made you look normal, and 5 made you look funny.
That's not what I was expecting. I thought it would be mirrors that made me look normal, and shiny surfaces that made me look all funny.
Not correct. Some mirrors did not reflect you normally. Suggest you examine mirrors only.
Show the mirrors that made me look normal.
Showing.
Show the mirrors that made me look all sort of funny.
Showing.
Question: do flat mirrors make me look normal, and ones with curves in them make me look all funny?
According to available scans, this is correct.
Prompt to assist.
Assisting. Suggest you test theory with more scans.
Right. Let's find some more flat mirrors and some more curvy ones.
XP tested his theory and found it was right. He saw ordinary reflections in flat mirrors and funny reflections in curved ones. Meanwhile, I'd found myself a magician who's going to help me with a trick.
Come in.
Hi, are you Mike?
That's right.
So you do all the magic and stuff?
Sort of. I do magic which can be explained by science and then get people to try and work out the science behind it. But I can do real magic too. I'll show you a trick. Here's a piece of rope. Two ends there. And make a loop in it like that. And now I'm going to cut the rope in half. There we are. Now let's join it together. There we are. That doesn't seem very magic, does it? Okay, let's use some magic on it. Get my wand. Rub it over the rope like that. Open it out. And the knot's disappeared.
So have you got any tricks to do with mirrors?
Yes, I've got a box over here which uses mirrors which look like magic. There we are.
So that's why I'm up here dressed like this. Anyway, my trick's all ready now. Let's see if it works on XP. My lords, ladies, and special visitor from another planet. That's you, XP. I, the great Swarovski, will now demonstrate the amazing magical vanishing cabinet. But first, I need a volunteer from the audience. You, sir, if you care to step up on stage. Now, I need to borrow something. Using my amazing powers of telepathy, something tells me that in your pocket you have a packet of crisps.
Absolutely right, Sarah.
Thank you. Sir, would you please look into the magic square? Keep looking at it as I take your bag of crisps and right before your very eyes, make it disappear. Do you have another packet?
Yes, sir.
Thank you. Look very closely as I take your bag of crisps and abracadabra, make it disappear. Thank you. What do you think, XP?
Wow, well, you said that was amazing. You must have enormous magical powers. I've known you all this time and you've never once let on. On my planet, only the almighty Weeble has such awesome power.
It was a trick, XP.
But not even his awesome... What do you mean a trick?
It was a trick. It was all done with mirrors.
With mirrors? I don't believe you. You mean mirrors at my crisps? No. You're pushing my foot.
I think you mean pulling your leg, and I'm not. Honestly, it was a trick and all done with mirrors. Should we tell him about it?
Yeah, why don't we? Well, it works like this. The crisps are in here, in a secret compartment, which you can't see because there's a mirror running from this corner here down to the corner at the back. The mirror gives a reflection of this half of the box in the mirror so that it looks like a whole box.
What about the ball floating in the air?
That's actually half a ball, which is stuck to the mirror so that it looks like a whole ball.
Extraordinary. Activate smart specs. Scan to confirm.
Confirming. The box is divided in half by a tilted mirror. Half a ball stuck onto the mirror looks like a whole ball floating in mid-air. What looks like the back of the box is really the reflection of the front of the box. Behind the mirror is a hidden compartment where your crisp packets went.
Extraordinary.
So, you see, XP, it was all a trick, just using mirrors. Anyway, what did you find out?
Well, Sarah, I learnt that from flat mirrors, you get normal reflections and funny reflections from curved mirrors. And it's the same with shiny surfaces. Flat for normal, funny for curved. What about you?
Well, I've got this really good mirror writing for you to try out, and a kaleidoscope. Are there any other good ideas?
Yes, you could get a couple of mirrors and see if you can see over high walls using both of them.
Well, now I shall show you two a trick, if you'd like to take a seat. The great Expeditious will present for you, lady and gentlemen, Soing the Magician in Half. Sarah, I'm in a bit of trouble. I've forgotten how to put myself together again. Come back, Sarah. Oh.
I hope you can hear me. I'll try and explain what's going on.
It all started when XP was in bed one morning, catching up after a late night watching TV. What are you doing at half term? No, on Saturday. It didn't take XP long to decide that noise was going to be the next thing he investigated.